Alright folks, problem 12c, want to find the solutions for this equation. So notice that both the first term and the second term there, remember terms are split by addition and subtraction. The first term and the second term both have a tangent of t in them. And so we need to factor that out. So let's go ahead and pull out a tangent of t. And what are we left behind with? Well, that first term has root 3 tan squared. We're pulling a tan out, so we're left with root 3 times the tangent of t. And then what about that second term? Well, minus tan t, and we're pulling a tan out, so minus 1, and that is equal to 0. At this point, we have a product of two things equal to 0, and so we can set them each individually equal to 0. So we can say the tangent of t equals 0, and we can say that root 3 times the tangent of t minus 1 equals 0, which I'm going to go ahead and say is equal to 1 by adding 1 to the other side. And so let's get that tan by itself. So tan of t then will equal 1 over root 3, which will rationalize to root 3 over 3. And so now we just have the questions, when is tangent equal to 0? We'll draw your little unit circle. Tangent is the slope. Slope of 0 means we're dealing with a horizontal line. So that would give us that point right there for t equals 0. It will also give us that point right there for pi. And then also we know that 0 is equivalent to 2 pi. So we need to include that as a solution as well. Now this one over here, not quite as obvious, tan of t equal to root 3 over 3, but you got to get your tan values down as well. Those right there will correspond to pi over 6 and also to 7 pi over 6. And you can get that root 3 over 3 by literally taking the y value and dividing it by the x value, because tangent is slope. And so we get those additional two values at pi over 6 and 7 pi over 6. And if we were asked for the solutions on the interval 0 to 2 pi, we would be done. But this wants solutions for all values of t. And so notice those purple solutions, 0, pi, and 2 pi. Those are all just multiples of pi. So if I start at 0 and I add pi, I get there. Well, add another pi, I get back there. And I'm going to continue to go back and forth like that, whether I go positive or negative, it doesn't matter. So I'm going to say t equals pi times n. And again, n is going to be an integer. So you can say where n is an integer, but I'm going to use fancy math notation and say for all n in the set of integers, like that. But you can say where n is an integer, that's fine. So that's one set of solutions there. What about these blue ones as well? Well, again, it's the same idea. If I go pi from that first solution, I get the next one. Go another pi, I get back to that same solution. I can go around as many times as I want. So for this, we're going to say pi over 6 plus pi n, because we need to go to that pi over 6, but then it's just multiples of pi to get us to the next solutions. And again, that's for all n in the set of integers.